Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about superacid and alkyne. So in this case, these triflic acid or triflamide, they are very strong acid actually, and reaction with this alkyne. So here four options are provided and one of them is the right answer. And I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry, after some time you will get the right answer with proper explanation. Now I believe you have tried by yourself, it's my turn to give you the right answer. So student, a very simple justification to you that this triflic acid or triflamide, they are extremely acidic, means their conjugate base Cb is very stable. So that's why they completely ionize and produces H+, and these H+ protonates this alkyne. Generally, alkynes are not good base because they are softer in nature. But since this acid part is pretty strong, I repeat, it's pretty strong, so that's why it ionizes completely, and catalytic amount of this acid is enough to protonate first this alkyne to corresponding double bond containing species, and later on water addition happens. So let's see this thing stepwise. So first step is the proton addition, because they produces H+, which undergo addition with this alkyne, fine, and it produces this three-member ring with a double bond. It's a very strained molecule. So in the next stage, this water molecule attacks with its lone pair. So now in this case, it is expected that water will attack here because there is a chance that it can break properly. This based on my understanding. So because if you look at this, the neighboring is phenyl group. So if these bond breaks little bit and positive charge develops here, that will instantly be stabilized by the conjugation with this phenyl group. So that's why positive charge density is more at this position. So water will attack here, and after attack, what it will produce? It will produce, this is one phenyl now. So there is double bond. So and hydrogen obviously here, and water OH2 plus, and in the next stage what will happen? These one proton will be released and it will be converted into OH. Okay, now student, there will be doubt that sir, this methyl is closer to phenyl. Okay, these hydrogen, it's okay, both you can consider. For example, that's why I've written both here. So this methyl closer to phenyl, or you can say that this hydrogen closer to phenyl, whatever it is. But if you look at this molecule little carefully, this is actually an enol, and we know enols are not that much stable, and it will instantly undergo tautomerization to the corresponding keto form. Actually, keto form is more stable than enol. Now, so in this case, a simple question may come. So this is the product. So the question is, how and why triflic acid is capable to protonate alkyne efficiently? So actually, since this superacid, very strong acid, conjugate base is very stable, so it completely dissociates and produces H+, and C. This conjugate base is very stable and it don't want to take its own proton back. So who will take? On obviously where there is electron density, and in this case alkene is relatively more electron rich because it has two pi bonds. And by the way, you can say that sir, there is one phenyl group, it's electron rich, pi electron cloud, is true, but protonation and phenyl group will destroy the aromaticity, means aromatic stabilization. So that's why please don't think that point of view. So protonation will happen on the alkene efficiently because of the extreme acidity of this triflic acid or triflamide. So that's why catalytic amount is enough to carry out this reaction. Now, so for little more understanding, you can look at the structure of this triflic acid. Its pK is minus, means actually it is more minus 14.7, means it's more stronger than concentrated sulfuric acid, and that's why it is called superacid. So why it's very stable? Because the conjugate base, I mean here you can see this O minus, is extremely stabilized because there is a CF3 group. Obviously these two groups are responsible for this resonance stabilization, but this CF3 group also has a very strong minus I effect, and that helps to overall stabilize this negative charge or conjugate base efficiently. So that's why it's acts as a superacid. Not only that, if you look at this trifluoride, so this NH proton is released and ultimately this N minus is produced, and which is obviously this resonance stabilized. I am not going other side because it is the same. So it could be donated here, it can with stabilize one way. Another strategy is using this, and not only that, this CF3 groups minus I effect. So this makes these molecules very strong acid, and that's why they can do this job. So in conclusion, what is the right answer here? In this case, is the right answer is option B. Now question is student that if this question appear in your exam less than 30 seconds, how can you come up to the right answer? Now you need to understand the condition. Water, dioxane and catalytic amount of trifluoric acid or trifluoride, very strong acid. It's true. So in this case, one thing is clear. So this is a very strong acid, so it will release proton. And who will react with proton? I mean comparison this alkyne versus this phenyl. So remember, aromaticity is a huge stabilization energy. So this aromatic ring will not be affected in this context. So consequently option D and option C gone. Now the competition is between option A and B. So in this case, I suggest you student, please draw the intermediate pH. So this is double bond, this is hydrogen with plus charge. Okay, so similarly 3-member ring intermediate, I guess you have seen in case of halogenation of alkyne, similar type. Okay, fine. Now if you look at the substituent, one side is methyl, another side is phenyl, and phenyl group has plus R effect. So if, and this is actually benzylic type position, you may think like that. So phenyl group can release its electron through plus R effect, and if there is some electron deficiency, that could be stabilized. And if you look at little closely student, this is a 3-member ring with a double bond having a proton cationic charge, so it's significantly strained. So that's why this bond is expected to break and positive charge will be produced here. Okay, so if positive charge is here, then nucleophile is expected to attack here. Here nucleophile is actually water, so obviously carbonyl group will be produced here. Simple. But student, I always suggest please read as much as you can, because that is the best guarantee to secure better rank or marks. Now in conclusion, what you have learned today, that trifluoric acid or trifluoric amide is a very strong acid, and they actually called superacid because they are more stronger than considered sulfuric acid, and this is due to the excessive stabilization of their conjugate base due to both minus I as well as minus R effect. And here the superacid is more stronger than considered, because I told, due to the minus I effect of fluorine and obviously CF3 group, that makes it special or different. And in this case, alkene or alkyne, if you consider one of them, is actually both are weak base or soft base in nature. So they prefer soft acid like Hg2+, means mercury 2+. However, the extreme proton release tendency of superacid actually forces this alkene or these pi clouds to be protonated. So this is the proper design of molecules. Now after protonation, this alkyne became electron deficient because it already added to a proton, means positive charge, so that's why it became electron deficient, and consequently water does the nucleophilic attack on it. And the position, which position it attacks the position having relatively more amount of positive charge density. And another thing, remember student, that keto-enol tautomerism prefers to remain the equilibrium towards the keto side as it is more stable, unless, I repeat, unless there are some other X factor which provides some additional stabilization. So generally keto-enol tautomerism, the keto is preferred. So this is the end of this discussion. I believe this video will be useful. I thank you everyone for watching this, and if you really consider the content of my channel is worthy, then please help this channel to grow. So stay happy, stay blessed. See you in my next video. Bye bye.